Welcome to the Zedboard Chronicles. I'm Larry Osborne, Senior Product Manager at ASSET InterTech. The purpose of the video chronicles is to explore the Zinc 7000 all-programmable SoC from Xilinx by recording my experiences. We'll be conducting experiments using the SourcePoint C software debugger from ASSET InterTech connected to the Zedboard from Digilent. The objective is to use the Zinc 7000 SoC as a learning experience. There are several chronicles planned. The chronicles will cover the PowerUp and JTAG debugger connection, executing dual core control, ways to initialize the Zinc 7000 SoC, poking around in the address space, reverse engineering code initialization, downloading code to the target, quad spy programming and debug, and others driven by viewer request and my curiosity. So let's get started. The board ships with the boot mode jumpers set to boot from quad spy. I'll start by booting the board and seeing the multi-stage boot process in action. The board starts by running some code on the on-chip ROM and looking at the boot mode straps. The loading of the first stage bootloader, in this case U-boot, and then loading the Linux kernel. I'll stop the loading in the first stage bootloader and then continue loading the Linux kernel. From the output of the terminal, we can see if the board has booted properly. Now I'll change the boot mode jumpers to boot into the JTAG slave mode. With a little video trickery, the mode jumpers are changed, and the SourcePoint probe is connected to the JTAG port. Now,
with the debugger open, I'll stop the processor execution, and in doing so, a code view on processor core 0 is opened. The code view highlights the program stopping point, which is effectively the program counter. By looking at the code view, we can see that the core 0 is in a tight wait for event loop. By opening a viewpoint, I can see that there are two processor cores within the Zinc 7000 SoC. Changing the viewpoint to P1, I see that the code window changes and we're tracking the program counter there as well. The code view is tracking the viewpoint as I move between the two cores. Opening a second code window, I can change the tracking of the viewpoint to be locked to a specific core. So in this example, I now can see what the code in P0 as well as in core P1. Notice that the core is in the same address range of the on-chip ROM that is designated for the slave boot area for JTAG. However, they are not executing exactly the same code.
So at this point, I've examined the JTAG slave mode boot code in the on-chip memory. To proceed further, I need to initialize the processing system. I need to write code and load it into the OCM or flash the code into the quad spy or SD card. That assumes that I've written and debugged the code, which I haven't. I'll cover that in episode 2. In this episode, we successfully powered up the Zedboard and examined the dual core nature of the Zinc 7000 all-programmable SoC from Xilinx. The next episode will examine ways to initialize the Zinc 7000 SoC, poke around in the address space, and finally reverse engineer some code initialization. Be sure to check out the web links below in the YouTube description for more information on the Zedboard and SourcePoint debugger.